Hi there, I'm Hao, and this is just another video of me solving random LeetCode code problem. So given an integer array nums, we need to find three numbers, not distinct, but three numbers that add up to zero, and the position of those numbers have to be unique, right? So I, J, and K, the three index has to be unique, and we are not allowed duplicate, okay? So we can find all combination of a triplet, but give us a very bad runtime. So we can improve the runtime by sorting the array and log in, and we can use the pointer to do this. We give it a runtime of n square, right? Um, it would be like this. Yeah, so O of n log n plus n square, so we can ignore this, right? Turn out to be of n square. So let's see how can we do this with a sorted array using the first example right here. So we can start I. So we iterate I all the way to length, right? -2, less than -2, because we want to use the left and the right pointer. The left pointer will always be one index after the I, and the right pointer will always be the last element. Right? We can keep track of the current sum, which is -3, right? If it is less than 0, we want to go to the right side to because going on the right side give us a larger numbers, right? And we are looking for a larger sum to 0, right? So that they are the same, right? So whenever as we iterate the left pointer and the right pointer, right? If we see the same numbers, we would just keep going, right? And that can save us a lot of processing time, even though the big O will stay the same, but it will be split up in the average case. So here, sum will be -2, right? Still smaller than 0. We go to here, so -1, right? And the next one, the last one here. And now they are overlap, and we need to have a distinct I, J, and K, right? So we just exit while loop and try it again. So I starting at the first position won't work. So we start from here, left and right. Our sum now is 0, right? Cool. We add it to our resulting array, right? So when the sum is 0, after we add it to the resulting array, do we want to increment the left pointer or decrement the right pointer, right? We actually need to do both at the same time. Why? Because if you think about it, this is our two numbers, right? In the triplet. So the only numbers that can make up to the sum of 0 is an integer 2, right? And if we ever find the number 2 again, then what does it mean? It means that we have a duplicate, right? So similarly, if we only decrement the if we only increment the left, right, and it is the two number that we have in the in our triplet, which is -1 and 2. So the only number that add up to 0 is -1, right? And if we ever find a -1 number again, it will be a duplicate. So that is why we want to increment the left and the right at the same time. Increment the left and increment the right at the same time. So now our sum is still 0. So we add our next triplets, which is -1, -1, 0, and 1, right? And then we keep increments to the left and decrement the right. They overlap, right? So we exit and keep incrementing the I. So when I is at -1, we can see that we already processed this node, right? So because the array is sorted, so any combination that make up to 0, right, had to be greater than or equal to -1, right? In that case, we have the -1, -1, 2, and -1, 0, 1, right? any number that make up to the sum of like a number, -1 has to be greater than or equal to -1. And we already processed that, right? We already processed that, which we found these two combination, right? Similarly, when we are here, right, any number that make up to the sum of 0 is really greater than or equal to -1, and we already processed that, so we don't want to process it again. So that is why we want to skip it, which help us a lot in the average case. We can speed up the processing time inside our nested for loop. Okay, so left and right. So now the sum is 3, right? It's too large, so we want to move the right pointer. So now they are overlapped, so we exit. Right? And we are done here because I is now equal to length minus 2 if we increment one more time. So that is the general algorithm. The space complexity is around, it's depending on the sorting algorithm, right? If we use an in-place quicksort, it would be a log of n. But if we use an out-of-place quicksort, for example, it would be of n, right? Okay, so let's code this up. So first thing first, you want to sort the input array a minus b, and we want to iterate through the input num minus 2 because we want to leave the space for our left and the right. So if I is greater than 0, right, and I and nums of I is equal to nums of I minus 1, right? We want to skip it, right? Continue because we already processed it, right? Otherwise, we will set our left and the right pointer. So left equal to I plus 1, left right equal to nums dot length minus 1, which is the last number, right? And y, left is left and right. We want to calculate the sum, right? Which is nums of I plus nums of left plus nums of right. And another thing we have to, we can see that we know that the nums, we have always have at least 3 elements, right? So that is good to know. So if the sum is less than 0, we want to increment left. Else if the sum is greater than 0, we want to increment the right? And else, which means the sum is 0, we want to add it to our results array. And we have to create that here, result. We want to return the result array again. Okay, so result dot push. We want the triplet, right? So nums of I, nums of left, and nums of right. Echo here. And we want to increment the left and the right, between the right at the same time, right? As I mentioned earlier. And we can even further optimize it by keep incrementing the left, right? If the next value is the same, because we just gonna have because if the two numbers are the same, then we're gonna have the same combination, right? So y nums of left is equal to the nums of left plus 1. We want to keep incrementing the left, right? And same for the right. For the right, it is the opposite, right? Right, minus 1. We want to use them on the right. Okay, and that's pretty much it. Let's keep it a try. Syntax error. What's wrong here? Left is I plus 1. Line 17. If sum is less than 0, num sub I, num sub left, num sub right. Yep. And y num sub left equals to num sub left plus 1. Yep. Result should push. Let me just refresh that because I don't understand what the error is. Okay, now it works all of a sudden. Well, I think it's just a LeetCode bugs. Okay, and thank you for watching.